Okay, recording has started and I'm just sharing my screen. Is it visible? Is my screen visible and my audio is clear? Can someone confirm over the chat channel, please? Okay, thank you very much. So, uh, as I have completed a brief introduction about myself, now let us have the introduction about our course, right? So, we are covering Power BI and PostgreSQL in this course. Okay, so Power BI means business intelligence tool. Okay, and PostgreSQL is a database. And what we are going to cover as a part of our course is three major topics we are going to cover: data warehousing, PostgreSQL, and Power BI. Right? These are the three main topics we are going to cover. Out of these three, our main objective is to gain extensive knowledge on Power BI. Okay, and to have a sound knowledge on the database, that is PostgreSQL and data warehouse. And why we should be knowing about the database and data warehouse, just I'm going to show you one end-to-end diagram. Okay, let me show you how the data flows. Now if you see this particular diagram, data to insights journey, right? And we all know currently all our businesses are being tracked digitally, right? Wherever we go, whether it's a small shop or whether it's a big Walmart kind of thing, right? Whether it's a banking, whether it's a petroleum industry, retail, fashion, everything, now we are capturing all our transaction through digital devices, right? It can be a tablet, it can be a laptop, it can be a sensors, right? Or it can be some kind of observation devices, all those things. Now everything is there are multiple devices are there that is capturing a huge among us data, right? We are having nowadays trillions and billions of data is being captured. Earlier when we talk about the data, we used to talk about MBs, GBs. Now it has gone beyond that one, picobytes, terabytes. That much data is being generated in the current world, right? Now, when this much amount of data is being generated, one thing is how to maintain that data is the first thing, and how we can achieve some valuable inputs from it, right? Or how we can make that particular data generates revenue for us. That is where this data analysis, data engineering, or Power BI, data visualization, all these things has came. Right? Now, whatever we see that the left side, if you see, this is a kind of data factory, right? Now, data factory means all our businesses, right? If we go to the shop, there would be a sales counter would be there, right? Or billing counter would be there. All the activities are captured in that billing counter. So that means a lot of data is going to be generated on day-to-day basis. Companies put a lot of money to organize that data. Now, if they are just keeping that data as it is, that means that is going to be a additional cost for them without no revenue generation. Now, over the period of time, like earlier we call it as a reports that gives an information about what happened, like annual reports, quarterly reports, right? With the technology as evolving, like visualization tools, business intelligence tools like Power BI, Tableau, right? And there are a lot many open source cloud solutions also there. With these coming, they have started generating the reports in the real time. If today business closed, by end of the day we will get the report how the today business has happened. Or we have the options to get the hourly reports also, right? So that is where the visualization part comes. So as a Power BI data analyst, what we are going to do is that we are going to convert the data into meaningful insights that is going to help to take the decisions by the top management, strategic decisions, right? Or day-to-day decisions by the operational workers. Both the things we can manage, right? It's upon how the what kind of reports we are going to create and what is the requirement. Now, how we are going to achieve this end-to-end solution, right? Data is being generated, there would be some front-end systems built, right? They are generating lot of data and they are putting into the files or in the databases. Now, in this journey, I want to show you one more picture, right? If you see, these are all different technology, or we can say technology stack that is being used, right? To store operational data, we are having databases, Cosmos DB, SQL, Teradata, Oracle, right? Or AWS databases, Google database, or Microsoft Azure databases, all those things are there. They are going to store the operational data, whatever the activities or events happen, right? And once we have this data stored, this is kept in a Azure data factories. Like we call these stages data injection or ETL. ETL means extract, transform, load. Okay. And we have like Azure Synops, Azure Stream Analytics, all those things are there. And once we have the data injected, we are converting that data into analytical data storage and processing. Why to put it into analytical data storage processing is because doing operational activities and the analytical activities on the same system will be having a performance issues. Okay. In the initial days, definitely these all things done on the one system only. But as and when the data is growing beyond the limits, right? Then new solutions has came up to address the ongoing issues, right? Like if you see the third one thing, analytical data storage. So whatever the data that is operational data is there, that is stored in a operational form, right? Now we are storing in the analytical data storage as is summarized. If I want to say it in simple layman language, right? That whenever we keep this operational data in a summarized form, like instead of every transactions, I'm going to keep day-wise transactions, day-wise revenue, month-wise revenue, quarter-wise revenue, right? So in this way, I'm going to store in the analytical world, right? Now, once we have this analytical data, then we are going to use data modeling and visualization, wherein which we have the Microsoft Power BI that is going to create the visualizations. Okay, a nice colorful visualization that is going to tell the story of how our business is running. As a part of this course, we are going to be the we are learning these skills, Power BI skills, right? So there is no hard and fast rule that yes, we all need to learn everything. But I would say that one, we should be subject matter expert in one of these tools. And at the same time, we should be having a sound understanding about what other tools would be doing. Okay. In the current world, what happen is that we may get say that, okay, there is a database, you have a lot of data sitting in it. Now you start reporting the things in the Power BI. Then how can we start? We should be having a basic understanding about the databases. Okay. So in this journey, there is a different people are going to work on it, like a operational person, a data engineer, a data scientist, right? A data analyst, and we all would be teaming up. Okay. So it's not like that one person to do everything, but a team of people who are specialized in their own area, right? Coming together, and they should be having an understanding about how other area is going to work, right? Like a scrum team where you would get different team members who is expert in testing, who is expert in development, who is expert in analytics, right? And they cross skill each others, right? But at the same time, they should be subject matter expert in their own area, right? That is what we are going to target as a part of our course. We are going to become a subject matter expert or SME for the Power BI. At the same time, we are going to use PostgreSQL. It's one of the open source database. Okay, so we are going to learn SQLs with the help of PostgreSQL. Right? Any questions or queries till now? What we are going to learn as a part of our course, right? So that I will be showing you how the Power BI looks, how the PostgreSQL looks one by one, and then we will see what are the opportunities and how we are going to work on the certification, all those things. Before I just go to the next uh, topic. Any questions, queries? You can post it in the chat channel if you have any queries or questions. Okay. Yeah. I would be coming on that one, Irfan. Okay. Just for a small update, after learning the Power BI, would be able to apply for the data analyst jobs. Okay. Or a business analyst job using through the Power BI tools and the SQLs. Okay. Fine. Now let me show you. So if you see, these are all the different types of solutions or technologies that is provided by the Microsoft. Like if you see data engineering, data factory, data science, industry solutions, databases, data warehouse, Power BI, right? And we don't need to worry that, oh, do I need to learn everything? No, but if you're learning Power BI, let us learn it completely like a complete. And at the same time, we are going to learn about databases, right? How to interact with the databases and having SQL, structured query language. Structured query language is like a universal language, like English, right? If you learn English, right, we can manage to, survive in majority of the countries in the world, right? Similarly, as a part of our course, with the help of PostgreSQL database, right, we are going to learn SQL, structured query language, which means once you join in the job, now you need to work on any other database, then with a small training and everything, we can easily understand those things because the underlying SQL is 90% common. Okay, optimistically, I can say 75% it would be common. Okay. And also we are going to understand these data warehousing concepts in detail, right? Because here it tells why we are doing all of these things. Okay, why we are segregating the operational data into analytical data. What is the main purpose of having two separate systems? What is operational systems is going to use per? What is the purpose of operational systems? What is the purpose of analytical systems? Right? How the data between these two systems would be synchronized on day-to-day basis. Okay. And from the course, right, within the data warehouse concepts that we are going to learn about the what are the different types of theories are there in Moll and Ralph Kimball, what is the theories they proposed, right? We are going to understand what is about OLTP or OLAP, data warehousing, data mart. So all these things we are going to learn as a part of our data warehousing course. Yeah, we are going to see the aggregations also. Okay, within the SQL, we are going to see the basics like creating the tables, creating the databases, creating views. At the same time, querying the tables, aggregation functions, group by, order by, all those things we are going to learn. Okay, so in the SQL, right? If you see, these are all the in the PostgreSQL, okay? And PostgreSQL is an open source database, okay? For your information, I can pick a database from the Microsoft itself, but what I thought is that yes, since we are learning Power BI from the Microsoft, let us have a exposure to one of the open source tool. Okay, guys, if you are not sure about what it mean by open source means it's a free of cost. We don't need to pay anything. We can install it and we can work on it at the full extent of the software. There is no limitations like trial version or what we call there's some basic features, not like that. The PostgreSQL is a open source, that means completely free. Okay, and it is one of the advanced databases in the major fields. This PostgreSQL is being worked out. Okay, whether it's an astronomer, jet fuel engines, right, or banking systems, asteroid tracking, all these kind of technologies areas, business domains, PostgreSQL is being used. Okay, and what we are going to learn in the PostgreSQL is more about the SQL, like DDL means data definition language, like creating the tables, right? Creating the modifying the tables, inheriting. At the same time, it's DML, data manipulation language, like inserting, updating, deleting the data, right? And also we are going to learn different queries, like combining the queries, join, sorting, filters, right? Aggregations and data types. This is one of the important thing when we are dealing with the data, that we should be having a strong understanding about the data types. If I'm storing a particular value in a column, I need to know what kind of data this column can store, that we are going to define. That's called data types. Okay. And this is followed by Power BI, right? In the Power BI, we are going to learn about how to get the data, right? How to transform the data, how to clean the data, all those things. Followed by analysis, right? Once we have data, when we cleaned up the data and we have fixed all the open issues, right? Then we are going to visual analyze that one, right? And once we analyze that, we are going to create a lot of DAX queries and all those things, and we are going to visualize, right? And then publish that particular dashboards or the reports, right? And we are going to cover all these topics in a detailed level at the ground level, right? So that you can easily start preparing the reports on your own. And we are going to get some tools also there that will help us to generate the data for our practice. And I'm also going to give a lot of exercises on the same. Okay, so we are going to learn how to get the data, how to clean it, and how to analyze the data in Power BI, and visualizing the data and publishing the data. Okay, as a part of Power BI, right, we are also going to cover some artificial intelligence tools also. Let me show you by opening the Power BI, because many people has a doubt whether the AI is going to take our jobs, right? These are the some common doubts comes to everyone. But what I would suggest is that what I'm strongly believe is AI makes our life easy if you learn it. Okay, we should be learning it and we should be master in using it, so that our jobs would become more and more easier. Excel, I'm not covering, okay, but I have my previous class recordings, okay. I can share Excel as a complimentary, okay. So just I'm opening one of our previous report. So this is how we are going to present our data, okay. to know how the business is going, performing, we can say. Like what is the total revenue, how much sale customers are there, how much boxes are there, whether we have made the revenue. Okay. And if you see here, we have some artificial intelligence visuals are there. We are going to master on how to use these artificial intelligence visuals as a part of our Power BI course. Okay. We are going to deep dive into the Power BI, no doubt about it. And our target is to secure PL 3, this one. Wait, just 1 second. Yeah. Microsoft Certified Power BI Data Analyst. Okay. This is the certification we are going to target it. And many people has a doubt. I mean, do we need to really complete the certification? Because see, we want to change our career, right? Earlier, we would be in the non-IT world. Now, how the organizations know, yes, this person has the right level of skill set in the Power BI once we crack this certificate. Okay. And this certificate, the separately we can register for this one at this point of time. You don't need to worry. Okay. Next 3 weeks, we are going to have weekday classes from Monday to Friday for the US colleagues. And for Australia, India, it is Tuesday to Saturday. Okay. Daily 1 hour course, but it will just, we will be taking like 1 hour 15 or 1 hour 30 minutes, not more than that. Okay. Because what I strongly believe is a class of 1 hour or 1.5 hours is good enough to understand and to grab the things, right? And all the classes would be recorded, and you would be provided class recordings in the YouTube with a restricted access to all the registered students. Okay. First 2 classes you are going to get access the same. Okay. For you. And at the same time, you are going to get some project tasks also. You need to complete those tasks as a part of your learning practice and send it back those tasks for me to review. Okay. So this should be a consistent and continuous process that we need to follow. Class is done. That doesn't mean, okay, we learn everything. Okay. Once class is done, after the class, before coming to the next class, that you are supposed to watch the recording. Okay. And complete the task, project task that I'm going to give it to you. In case if you are having any issues, then I would be there. Okay. We would be having a WhatsApp group. In that WhatsApp group, you can post the your doubts and everything. I will try to revert back as early as possible. Okay. This certification, Microsoft Power BI, right? This is going to intermediate level. Okay. We are targeting to complete an intermediate level of certification because our main aim is to crack the job, right? That means the recruiter should know that yes, we have a sound understanding on the Power BI and we have hands-on experience. Okay. Every 12 months we need to renew this one, but that doesn't mean you need to pay again. Okay. It's a free of cost renewal. We need to take the test again to make sure that yes, the person has known the topics and he is still, I mean, he has a refresh of his knowledge. Okay. And there are different topics. The good thing with this is we are going to have some practice tests. We can take lot many practice assessments. Okay. When we are scoring continuously 80%, that means yes, we are good to take the exam. Okay. So the exam costs around $165, and this is going to be for Microsoft only. Okay. And you can select your country so that it will show whatever the currency in your, I mean, whatever the cost of the exam in your local currency. Okay. Uh, can you show job requirements? Yeah, I'm going to come there, Irfan. Timings class in AEST. AEST means which country it is? Harsh? Okay, Australia, it is around 11 a.m. in the Melbourne time. Okay, 11 to 12. Yeah. Okay. So this is about the certification, right? Uh, it's going to be very easy, okay, not too hard. It's just about we need to do a continuous practice on those things. Okay. Now coming to the openings, suppose if I just query on Power BI jobs in USA, see 8,800. Now if I click just the LinkedIn, okay, and see manager data analytics and reporting SQL and Power BI, the first one I'm showing you, right? The whoever dealing with the databases or data related, definitely SQL is a kind of a additional advantage for us. Okay. And what I would suggest is better to have, we should be having SQL knowledge. That one I strongly believe. Yes, we are going to cover SQL. Okay. So our course is like that: 10% data warehousing, 30% SQL, and rest of the 60% we are covering the Power BI. Okay, so like data warehousing and the SQL are like minor subjects, and Power BI is going to be our major subject. Okay, and classes are going to be every day, 1 hour. And if you see the 86K per year to 150K, okay, junior data analyst, what it is asking, a remote working, ETL development and data cleanup documentation. See, proficient in SQL, and this is related to Python. Okay, let us find out the jobs those are related to Power BI. Okay, and we can search with the experience level also. Okay, to be precise, what I would be going is associate and entry level. Okay, honestly, because we are not going to go mid or senior level at this point of time. Internship, show the results. I'm just further drilling down, and just let me do the search. And even we can ask the Google also, that is going to tell us how much openings are there in the Power BI world. So these are all different openings if you can see. Okay. And we can see what are the market leaders. Let me type, ask the Google Copilot. A guide to top 10 data visualization companies. See, these are all the things. Tableau, Microsoft, Power BI. Okay, Microsoft Power BI adapted integrated sitting at TIPCO. And the good thing with Microsoft Power BI is it's a Microsoft one, right? So which means that we can easily learn, understand the things. Let me show you one interesting fact here, right? If you see here the Microsoft Excel, right? This is the Microsoft Excel, and I'm sure many of us has worked on Microsoft Excel and Microsoft Word, right? I'm just taking a blank one. Like how the UI, user interface, is arranged. Like if you see, we have different tabs, and each tab has grouped with the common features that we can work on it, right? Similarly, if you see in the Power BI also, the home, getting the data, querying, inserting, right? And visualizations, insert. Okay. So what I strong or honestly feel is that Microsoft Power BI is easy way to land into the IT world, because even though we are in non-IT, right, we would be having, sure, we would be working with the Microsoft Excel and the Word, these kind of tools. That means whenever you have started working with the Microsoft Power BI, right, you don't feel that, okay, something, a new one I'm working. You feel that, okay, these are all options that I have earlier seen, right? And we are going to cover the A visual. So A visuals means that they are going to use the machine learning internally, and they are going to help us, right? Whatever the report that we are keying, suppose if you say this ask Q&A, right? If I ask total revenue by, right, uh, product name, let me get it into the focus mode. See, so while we are typing, just we are telling to the Power BI, hey, can you please get me the total revenue that I got by product name? See, it is going to give us simple bar chart, right? But to use this one, yes, we should be starting from the foundation. Okay, we are not going to directly to the AI visuals. Okay, AI visuals we are touching during the end of the course. Okay, before that one, we are going to understand more about the basic concepts, how to fill it and how to use all those things. Okay, say total revenue by product name or total revenue by category. See, I strongly believe Microsoft Power BI is a one-stop that where we can easily learn the things and crack a job. Okay, and as I show you, right, jobs, there are huge job market is there into the Power BI. If I type here Power BI United States, see, if you scroll Power BI report developer, full-time remote, analyze, interpret complex business requirements, design data models. We are going to learn, develop interactive, visual appealing Power BI dashboards and reports tailored to stakeholders, identifying and tracking key performance indicators. So another one advantage of learning Power BI is, let me tell you one thing. Uh, Let me get to this one, right? If you see this diagram, right, the Power BI sitting is extreme right side, right? Who are going to use these things? The business, the actual business people, right? The organization, top management. So that means we would be having a great opportunity to work with the business leaders or the top management in our organization, right? Suppose you are a data engineer, Azure Data Factory engineer, or Databricks engineer. Obviously, you are going to majorly connect with the Power BI data analyst, right? Because these are like interacting. Okay, hey, what requirements you need? Accordingly, you are going to build all your analytical storage processing. That means the stakeholders for the Azure Data Factory engineer, data engineer, or Databricks is mainly the data analyst. That is going to be we. And we are going to be a bridge between the data engineers and the business people, right? So that means whatever the work that we are going to be, that is going to be directly visible to the business people, right? How is power, and we can have a exposure to the top management, right? So think of it just in the terms. I have a question, just I'm reading it. How is Power BI sufficient to be a data analyst, or we need to have other tools like Tableau and Microsoft Excel? Okay. Uh, Power BI and Tableau are like a market competitors, Ash. Okay. And Tableau is completely a different tool. Okay. But the work it is going to do is the business intelligence. Okay. And you can see the comparison between Power BI and Tableau. But having Tableau is good. Sorry, having Power BI is good enough. Again, we don't need to learn Tableau. Microsoft Excel, it's like a basic fundamentals. Okay. Having knowledge on Microsoft Excel is going to help us. Okay. If you're registered, then I can provide you as a complimentary the Microsoft Excel videos. Okay, for whoever going to register for Power BI. Okay, because almost 3 years back, I used to teach Microsoft Excel, PowerPoint, MS Word, these kind of Microsoft Office tools. Okay, it's a 5 hours class. Okay, I can share it to you as a complimentary. Okay. Uh, any other questions? Yeah, I'm just sending you the link again. Just 1 second. I'm posting the student information link. Okay, kindly request you to. Oh no, there is a plus symbol added at the end. Let me delete that one. Okay, so okay, let me pause the recording for now. Okay, I hope you're able to see my screen and I'm audible, right? I'm just taking one new tool, blank report. Okay, so if you see there are different options are available in the get data, and we are having some quick options also like Excel workbook, one lake, SQL server, enter data, data and everything. And we have the get data. And if you see when I click on more, we have different options like files, databases, Microsoft Fabric. Okay, you name any particular tool, Power BI has the capability to connect. Okay, to be optimistic, I would say 90% of the tools can be connected. I mean, Power BI can connect to the 90% of available softwares in the current world. Okay, all these things we have different tools. Okay, now let us want if we want to get the data from Excel. I'm just selecting, connecting, and Excel practice, Power BI data, open. Okay, so the good thing with Power BI is it will reads the data and it will shows us what are all the tables or data is available in this sheet. See here. Okay, we just need to go through the data. Just we can have a initial check and we can select whatever the things that we want. Okay, if the data is looking good, right? Suppose simple consideration, if we are putting the data from already structured systems like data warehousing, databases, then almost they look pretty straightforward and we can straightly load it. Okay. But if you would have heard the word of data lakes, cloud, right? Where data is stored in different forms like images, right? Documents and all those things. So during that time, definitely we should be transforming the data, right? For now, I'm just loading the data. Okay. So all the 4 tables are loaded. And if you see here in the data pan, it's getting loaded. See, the tables are loaded and with along their rows and columns. Okay. And if you see on the left side, we have report view where we are going to create all our reports. At the same time, the good thing with Power BI is it provides us the table view also. Okay. So if I select the table view, I can see the data that I downloaded into the Power BI. Okay. Similarly, there is a model view is there, right? So this is the one that is going to tell us how our data is organized, how the relation between the tables are there. Suppose if you see here, there is a relation between people and sales, and it is having one to many. Normally, whenever we have the star, we term it as many in the database language. Okay. So if you see the columns which having the relation, they are highlighted. So in the people's table, we can have only one record for salesperson, but in the sales table, you can have multiple records of the salesperson. That is the terminology here. Okay, we are going to learn more when we cover the data warehousing topics here, right? Now let me come back to the report view again, right? Now, if you want to see the total revenue, right? If you see here, we are having different visualizations. These visuals are going to use the data that we pulled into the Power BI and visualize us about the details, right? Now, if I take a simple cards visual, let us have it. And the good thing with Power BI is, as I told you, right, it looks like a Power C. You have multiple pages here. Like in Excel, we are going to have multiple sheets. Just 1 second, things to be hang.
Yes, you are audible.
Okay, thank you. It, okay, don't send. Okay, see, this is the cards visual, right? Now, if I put total amount here, just I'm dragging and dropping. See, this gives me a single value of what is my total revenue. If I can rename it, right click, rename the visual, revenue. So this is my total revenue that tells in a single point, right? So whenever business people are there, they just want to understand what is the total revenue we are getting. Now, if the same value, if we want to know how this revenue is distributed, right, from which all the products we got this revenue, then we can use a bar chart, stacked column chart, and all those things, right? And another thing is Power BI is a combination of arts and science. Getting the data into Power BI comes as science, and how we are presenting it is going to be arts. Okay, x-axis, see we have the total. This 44 million means approximate like 43.8 million. Now, if I want to get the distribution of it through the product, right? So these are like standard visual that we are going to have. Along with this one, we have the A visuals, right? Again, I don't want to drag and drop all those things because I'm not sure about it. Then we can ask Power BI. See, count products by geography. So it is providing us some suggestions. If we are fine with this, we can use those things, or else we can have our own number of products by geography. If I click on it, see, I'm going to get. Okay, we can ask a new question. Total amount by category. See, bars, bytes, and others. So I'm going to show you how we should start from basics, right? At the same time, what is the fastest way to do the things? Both the things we are going to cover in the Power BI. Okay, and we are going to see all these visualizations, and we should be understanding which type of visualization is required for what purpose. Suppose if you want to compare between two things, how we are going to see. Suppose if you want to show something over a period of time, right? how we are going to present them. All these kind of things we are going to see in the Power BI. Okay, a detailed end-to-end learning about the Power BI, and at the same time we are going to learn the SQL and the data warehousing. Okay, any questions or queries? Or else we will just start the first class. Okay, if we don't have any queries, we will start the first class and I will be covering the what are the topic, those are covered in the first. Okay, so as I told you, right, so we are going to have 15 days class. Okay, daily 1 hour, Monday to Friday for US people, and Tuesday to Saturday for Australian people. Okay, so the charges are like 300 US dollars, 250 pounds, or 450 Canadian dollars. Each and every class recordings would be provided in the YouTube. So the good thing with YouTube is, yes, you can watch them at any point of time, even if you're traveling, right? You can just watch, keep in notes of it, and then once you are back to home, you can start preparing. Okay, and I'm going to provide the guidance on certifications, resume preparations in interview, and from our hack organizations, right? From our hack organizations, we have a dedicated team also. Suppose if you are not having time to do these resume preparations or applying jobs for the interviews, we have a separate team sitting in India. Okay, so that they would be helping you based on the service that you are going to take. Okay, along. So what are the questions we have? Do we have learn algorithms? No, algorithms not required because Power BI is going to do for us. We will cover Power Query Editor. Yes, Power Query Editor would be covered as a part of the Power BI. Harsh, okay. So Power BI, we are going to drill down in detail. SQL till intermediate level. Okay. Yes, Vishwajit, as a part of our day two class, I'm going to give you the project task, those to be completed. Okay, so we are going to have daily some task. Okay, that is kind of creating the projects and everything that comes in line with our course. Okay, and daily 1 hour followed by assignments and all those things. Okay, any questions or queries, or else we will start the first class. Okay, Lakshmi, do you want to add anything if you are there? Okay. So let me walk through you in the first class. Okay. So what I'm going to give is we are going to cover today first class data warehousing concepts so that it will helps you to understand how the class is being delivered and if you have any doubts and all those things. Right? Is it make sense?
Yes.
Okay. Thank you. I'm just keeping mute, huh? Just for to avoid any noise. Fine. Um, Data warehousing concept. So what is data warehousing? So let me open a simple white page. Okay. Now, many of you heard about the word warehouse. I hope so, right? Where it's a place like where we keep either raw materials or finished goods, right? When we say raw material, that we keep them so that the input cost to make sure that we are not having external shocks. Suppose if input the raw material we are purchasing when the prices is low, then we purchase it and keep it with us. If we feel that storage cost is lesser than the price variation, right? Similarly, the finished goods, right? Now we have a lot of production lines are there and all the units are ready, but the market is not good. right? So that means we keep them in our warehouse so that when market is good, then we can release it, right? Sometimes there would be seasonal demand. So for all this kind of thing, we keep a warehouse. Similarly, right, in the data world also, this kind of requirement is there. So what they decided is, okay, that I have a operational systems, right? And I don't want to keep more load on it. So I want a place where I can keep a copy of it so that whenever I want to use or wherever I want to use, I can use it, right? So on that particular idea, we got this data warehousing concept. Let me get a one picture, online picture, right? And let's say one picture tells 1,000 words. That I believe that is the reason these Power BI visualizations tools have a lot of demand, because by seeing those reports and everything, people can easily understand how our business is moving, right? Data warehouse. So I'm going to get the basic one, which is simple and easy to understand. So this is a simple diagram, age-old diagram also, but this still intact, like how Newton laws, right? Whatever the technologies that we are seeing in today's world, right? But the Newton's law, which we learned in the 19th century, early 19th century, still it is intact, right? Similarly, whether you are using Microsoft Cloud tools, Google Cloud tools, or Azure or AWS, whatever it may be, but the underlying concept is still intact. What it says is that I have a operational systems on the right side, sorry, on the left side, right? They are going to take care of my day-to-day business activities, right? I have a system, a database, okay, that is capturing all the sales information. Daily, whenever we are going to the Walmart, whenever we purchase something, everything is captured here, right? A sales database, a marketing database, or a flat files related to the employee information, right? All these things are being captured day to day on a daily basis, right? Now, what happening is, over a period of time, the requirements are like that. Okay, boss, I want to understand how my business is trending, right? Or how many employees are there in the organization, how much salaries that we are paying to the employees. So all these kind of questions come. Then what happen is, the analytical team started querying on these operational databases only, right? So on one side, it is serving to the day-to-day online activities, and also now analytical team is querying the data on it. So whenever they need a aggregated view, obviously we need to read entire table, right? Suppose if I want to know what are all my total employees, then I need to scan all the employee table, right? So that means there is a extensive querying is happening on the systems, and this resulted in the poor performance for both the online activities and the analytical activities, right? So on that ground, it is decided, okay, let us don't disturb this particular system, which is mainly designed for online processing. Take a copy of it, right? Say today business is completed, business hours are done, nothing is being run on this one. So let us take a copy and put it into the separate system. Now, how we want to put into that system is a like copy. Like if you see here, we have the raw data, right? A like to like copy, just keeping a copy here so that whenever I want it, I can use it. A summarized data, say I'm having one record for each and every transaction. That would be there in the raw data. But querying this raw data every time would be taking huge amount of time. So what I do is I will do a summarized data also. Say total end of the day balance, right? Or day wise revenue generated, or store wise revenue. I have 100 stores. I want to make sure each and every store, what is the revenue generated. So these kind of summarized data, we will keep it. And at the same time, a metadata. Metadata means information about what kind of data you are storing. So this metadata would be telling us, okay, boss, Harry's project is having a table that stores store-wise data, branch-wise data, or city-wise data, all those kind of things. Okay. And in the database world, right, if you see these, just let me show you some shapes, right? This particular thing, magnetic disk, this represents a database. Okay. What I feel in general is database is like a house, like all of us having house, right? So within the database, right, within the house, what we do, we will just partition into different rooms for different purpose, correct? A living room, a kitchen room. Similarly, within the database, right, they are further again partitioned with tables. A customer table going to have all the customer information. A employee table, employee information. Sales table. Okay. If you compare this one with our house, then it would be, we can easily correlate this one. Okay. Now within our house, we have rooms and they are connected with doors and everything, right? Passage. Similarly, these tables are connected with a relational columns. That's what you have seen here. Say a sales table and people table is connected with the salesperson name. And these connections should be logically. Please remember that one. I can't connect randomly. That is not going to give a meaningful value to me. Okay. And we are going to learn further what is this relation about it. Even if you see the product table and the sales table are connected with the product column. Right. So the databases which maintains the data and these relationship between these tables, that is the reason we also call them as relational database management systems, RDBMS. Okay, just giving a crux of it, of the database. And these databases are going to sit in the database engine. Okay, like a city. We can have multiple databases within a shape fill, no fill. Okay, we can have multiple databases. That means multiple houses within the single city or a street, like that kind of thing. Here also same thing. You are having multiple databases sitting on a single data warehouse system, right? And these are related data tables, relational database management system. Okay. Now, the left side part, which is dealing with the operational things, right? So those things we call as online transactional processing systems. And the right side part, we call it as online analytical processing system, OLAP. This is termed as OLTP. Okay. So this is the main purpose, right? Now you are seeing data warehouse here and there are some data marts also, right? Now who has introduced this theory? right? We are going to see that one. Before that, let us see some basic characteristics of the data warehousing. Okay, and from the AWS, we have a nice article for the data warehousing. So wherever the articles that we pick, right, the we pick it based on the best way that while reading that one, you would be easily able to understand those things. That is the reason. Okay, so I would request you all the knowledge articles that I'm going to share, kindly go through them without missing, right? A data warehouse is a central repository of information that can be analyzed to make more informed decisions, right? Data flows into data warehouse from transactional systems, relational databases, other sources. Business analyst, data engineers, data scientists, these are the things, right, we discussed before our call. And decision maker access data through BI tools. When you say BI tools, our Power BI, right? Or Tableau, or some of the machine learning, all this comes. Data and analytics have become indispensable to business to stay competitive. So data is going to help us to stay in the market and also to grow in the market, right? Data and analytics. So these are like a kind of a close words. We should not be confusing about these words. We have the data, we are doing analytics on it to find out answers to the questions like what is happening? Am I going in the right direction? Is my business improving or flat or decreasing? These kind of things. Business users rely on reports, dashboard, and analytical tools to extract insights. Right? So these are the points that we should be learning. If I wake up you at the midnight and ask you, hey, what it means, that you should be in a position to tell that one. Okay. Tools, Power BI, these are like tools we would be more interested, but this is the fundamental and foundations that we should be very clear so that we know why we are doing all those things. Okay. And some key benefits. See, what are the benefits of using data warehouse? Informed decision making, consolidated data from many sources, consolidated data from many sources, historical data analysis. So we are going to keep all the raw data. So that means whenever you want to do some analysis for a new requirement, yes, you can do the analysis. Data quality, consistency, and accuracy. This is very important. This is the key feature for data warehousing. Separation of analytical processing from transactional databases, which improves performance of both the systems. Okay. And data warehouse, database, and data lakes. So when you say data warehouse, right? Like in our warehouses, we all know, right? Whenever we say warehouse, everything is arranged in an organized fashion, right? You don't see something like irregular. Within the warehouse, we keep separate racks and we follow that one and we capture all those things so that we can easily retrieve the data. Now, when you say data lakes like Hadoop systems, right, where we can store images, documents, some kind of a unstructured data. Okay, even we can say data warehouses are used to store the structured data, like in the tables, clearly data types defined and everything. Whereas data lakes are used to store the unstructured data like images, online tweets, right? Or some kind of documents and all those things, right? We have these structured, semi-structured, and unstructured. Okay. So when we come to the cloud, again, it's like capable of storing the unstructured data also, where we don't have a proper lineage that whatever comes, we capture everything and then we do the analysis of it. Okay. Now, with respect to data warehousing, we have two great scientists, W.H. Inman and Ralph Kimball. Okay, so these are the two great scientists, right? They proposed the solution of this data warehousing. Okay, so now what is their proposal? Both of them has proposed their own approach, right? And till now both are successful because both are having their own advantages and disadvantages. It's about understanding which approach best fit for the purpose and use it, right? Now what Kimball has proposed, they are like Newton laws, like how Newton laws are important, right? Similarly, these both Ralph Kimball and Inmon are still intact, right? Now what Kimball is saying is we have different source systems sitting, right? Now he's saying about create a data mart for each and every source system. Now when I say data mart is also a data warehouse only. Like what are all the features of data warehousing is having same features. Storing the historical data, storing summarized data, right? And having the metadata. Now if I am having a manufacturing department, I'm going to create a data mart. I have a finance department, I'm going to create a data mart. And finally, I integrate all of them into single data warehouse. So this is like um, people who are learning the Scrum, right? Divide the work into the actionable items, small actionable items like BO, business outcome, right? Creating data mart for finance team is a business outcome. Creating a data mart for the manufacturing department is a data mart. Now, consolidating all the data marts into single one is like a epic, a data warehouse for the entire organization. This is what Kimball has proposed. And what Kimball says is that this approach is faster and this needs a team like generic skill set specific to that team is enough, that I don't need a skilled persons who understand entire business. I need some persons who knows about their department, they can manage it, right? So what Kimball says is that this is the iterative process and faster and good for the reporting and everything. Okay. And on the other side, Inmon, right? What Inmon has proposed is, boss, I don't want to create individual data marts at the first. Let me get all the source systems at one place. We also call it as enterprise data warehouse. That means let us have all the systems at one place, get everyone, and try building a data warehouse so that we have the single source of system. We also call it as ADS, or authoritative data sources, ADS, authoritative data sources, right? So what he says is that get everything into a single data warehouse, create the data and all the required, and then create a copy of each and every data mart. Say if sales team need a reporting on the sales happening, let us give access to only that particular domain by creating some logical views. So on top of these data marts, they can create the cubes and the reporting. Okay, both are successful based on the organization needs. Now let us see a comparative analysis of these things. Introduced by Ralph Kimball and Bill Inmon, right? Approach. If you see Kimball, it has a bottom-up approach. That means we are going to build a data mart for each and every department, and then we go to the central level, to the head office kind of thing. So that is the reason it says bottom-up approach, right? Whereas Inmon is a top-down approach, right? At the enterprise level, we start building, we get a data warehousing like employees level, at vendors level, at the product level, at the customer level, all those things. Okay. What is the benefit of this one is, suppose in Kimball, each department may create their own employee table, right? And sometimes employees move from department to department. That means there would be multiple tables, employee tables are created. There may be chances of data redundancy. Whereas in Mon, since it's a top-down approach, we will get creating one employee table for entire organization. So there won't be any data redundancy. Okay. Data integrate, it focus on individual business areas, a particular department, a particular business, whereas it focus on enterprise wide areas. Here it is. Say a table for the employees, a table for the customers, a table for the vendors, all those things. Yes. Build time, yes, it is efficient and take less time, right? Because we know we will be starting with smaller blocks and we start building on them. And as and when the first thing is completed, we would be going to the second one. It is complex and consumes a lot of time because first of all, getting all the department SMEs at one place, that is the challenging, right? You need to find out a time where all of the department subject matter experts or key developers and everyone, we need to pull everyone, start doing brainstorming and understand how each and every department is related to other department and all those things, right? Cost, it has a iterative steps and is cost effective. Yes, I'm going a step by step. Initial cost is huge and development cost is less, right? Initially that to getting all of them and getting a design finalizing and everything is a huge cost, but when you start developing, yes, I'm going to be cost effective because I'm going to create only one employee table or one product table for entire organization that would be referred by each and every department, whereas here there may be chances that we are going to create multiple data redundancy. Skills required, it does not need such a skill, but a generic team will do the job, right? Marketing department, sales department, finance department, they can do. It needs a specialized skill. Here maintenance is difficult because if every department is creating their own data mart, right, then I would be end up with multiple data mart, or within that multiple data marts there would be same kind of tables would be there, right? Here maintenance is easy. This is the one of the best thing. Maintenance is easy, right? Because we are going to keep a single place. Data model, it prefers data to be denormalized, right? Now guys, I need 15 minutes from now. Okay, I'm going to deep dive into one of the topic and where I need all of your attention because this is going to be a success factor, one of the key factors for our success. Denormalization and normalized. Have you heard about this word? Denormalized and normalized, right? So what it's saying is the data model, it prefers data to be in denormalized model. Okay. For this one, I have a data ready. Let me take that data. Normalization and denormalization. Okay. So first I'm showing you how denormalized table looks it. Okay. From that, we are going to come to a understanding how the normalization also going to be there, right? Say this is my sales table. Okay, where I'm capturing the all the information related to the customer product and what is the sales has happened in a single table. Okay. Now what happened when we say in the operational side or operational systems, right? We go to the shop and we say, hey, this is my billing number. When we give our bill number, that all the information related to the customer or related to the product, everything should be displayed on the screen. Will you agree with me? Right? And it should come very faster also. It should not take more time. So What happen is I need to keep maximum information in the single table. Okay, so storing the maximum details, those are required in a single table is called denormalized tables. And what is the problem with denormalized table is, suppose if you see Harish as a customer, we are storing his name and his address. Similarly, Michael, Dirk. Now just think of it, if I'm a regular visitor to that particular store, and if I'm storing, they are storing my information repeatedly, right? So that means we are storing the data redundantly, right? One way the data retrieval is faster, that is the advantage for this one, right? But the other side of it is that I am storing the data repeatedly or I'm duplicating the data, right? And to store more data, yes, we need to purchase the disk space that is going to be costing for me, right? So now they have come up with the normalized approach, normalization. So what is normalization is, instead of storing a detailed information, right? For this address, what I'm going to store, I'm going to create an address table and I'm going to give a unique reference number, right? Unique reference number. In the database terminology, we call them as keys or primary key. Okay, I want you to remember this word. In the database terminologies, right? We call the row, the column that is going to uniquely identify a column is called primary key. Okay, or unique identification. Now what I'm going to do is, for each and every address, I'm going to give a unique key. And when the sales are happened, I'm going to use this unique key, right? Now, if you see here, instead of storing some 10 or 20 characters or 50 characters, I'm just storing a unique identifier, right? So storing the data into multiple tables, right? Right? By reducing the redundancy, we call it as a normalization, right? And the key that is used to represent a unique value is primary key. And the same key value, when it is referred from the sales table, we call them as foreign keys. Okay, so address ID 1 is a foreign key in this table. It is going to help identify, get more details from the customer address table. Okay, so these two tables are related with the column called address ID. Okay, and this table, address table, we call it as a dimension table. And the transaction table, which is referring to this dimension table, is called as fact table. Okay, so the major advantage of this one is reducing the data redundancy. All the analytical systems follow the maximum normalized form. Okay, Surharsh, right? So in a denormalized form, okay, guys, I'm repeating this again. In a denormalized form, we are going to keep maximum information in a single table. Okay, either it can be related to the customer, it can be related to the employee, or it can be related to the product. The data retrieval is faster, that is advantage, but the disadvantage is we are going to store a redundant data again and again. If you take a city like California or Texas, where you would be having more number of customers, they coming repeatedly, so in that time it would be problematic, right? So that is the reason the data warehouse, right, where they may not require to get the data faster for single records, right? They go with the normalized approach. Now, normalized approach is we are going to give a unique ID for the address or customer, right? Similarly, I can create a customer table where I'm going to give a unique ID or primary key for each and every customer. And when this customer comes to my store, I am going to use his unique ID. Okay. So to show you this, yeah, in this, the sales table is going to be fact table and the address and customer table are going to be dimension table. Okay. To better have an understanding about this one, let me show you one diagram. Yeah. And this topic is from the our Microsoft Power BI only. Okay. I just want to show you one statement that tells, yeah. If you see this diagram, my sales table, uh, here it is, sitting at the center, that is going to store all the sales information. That means the facts. What has happened? When we say fact, what is the fact? I have purchased something. That is a fact. That is an event, right? What is the temperature? So these are all like capturing the day-to-day activities. Those are stored in the fact table. And to effectively maintain this in a normalized form, right? I'm going to use these dimension tables. Like if you take a table, hey, what is the dimensions of the table? Length, breadth, height, correct? If you have a square, what is the dimensions? Square would be having side, right? If you have taken a cube, what is the dimensions? Length, breadth, height, right? Similarly, if you have a rectangle, what is the dimensions? Right? The length and the breadth. Similarly, for this sales table is going to be supported by the dimension tables of products, sales territory, employees, and resellers, right? That is where here it says normalization and denormalization. To understand some star schema, and we call this particular schema as star schema. Why we are calling it a star schema? Because it looks like a star. Fact table sitting at the center, surrounded by all your dimension tables. Okay. In the current world, right, even in the Power BI also, it is hard to create a visualization with one table, right? So this star schema is a practical thing that if you want to get a nice visualization, yes, you should be having this star schema sitting your fact table sitting at the center and corresponding dimension tables. Okay. Now, if you want to filter something, let me come back to here. If you want to see, okay, I want to get sales from a particular city, right? Then we are going to use the filter condition for the dimension table where city ID is equal to 1 so that I will get all the sales related to the city. Okay. Again, within the customer address, right? The city ID and state name are going to be repetitive, right? Because within the city, you are going to have 1 million people or 100K people. So instead of me repeating these city name and the state again and again, right? I will again add a relationship that I'm going to store only city ID and this city ID specific complete details, whether it's city name, state, country, everything I store in the city table. Okay. And if we are having this multi-level relation, then we call it as a snowflake. Okay. If we are ended up with only one level, parent, child, then it is star schema. Okay. But again, your dimension table is referring to another dimension table like parent, child, grandchild, 3 levels. Sometimes it would be 4 levels also. Okay. We can have it. Then we call it as a snowflake schema. Okay. The advantage of this one is you would be reducing the data redundancy, but at the same time, your data query time increases. Okay, because if you have three levels, whenever I'm querying with city name, suppose if I provide city name as New York, right? Then you need to drill the city table, sales table, customer address table, and city table. So just think of it. If I want to pick some item that I need to go to three rooms, that means my response time would increase. Correct? So the more normalization you create, then the response time of your queries increases. Right? Will you agree with me? So all the dimensions, so I'm just repeating some questions, okay, which I got into the chart. Is the sales table and the address and the customer table are the fact? No, sales table is going to be the fact one, okay, sitting at the center, and the address, customer, these tables acts as a dimensions, okay. So all dimensions are part of the inside of the sale table, okay. All dimension tables are referred by the sales table for more detailed information, okay. Obina, is it clear? All this fact table is going to refer its dimension table for more detailed information. Okay. Foreign key will be the foreign key will be in the fact table and primary key is in the fact table. Foreign key will be in the fact table. Okay. And the primary key would be there in the dimension and the fact table also. Because see, primary key is a kind of a unique identifier. Okay. Even this fact table should also be having a unique reference number to represent a particular record. Like if it is sales table, then you would be having a order number. Okay. The what we call it as, I'm not getting the unforced rule. I mean, there is a rule, okay, which databases don't enforce, but they tell that all your tables should have a primary key. One column or multiple columns can cover as a primary key, but make sure that your tables has a primary key so that each and every record can be individually identified. Okay. Now, if this primary key used as a reference in other tables, then it is termed as foreign key in that particular table. Okay. So let me show you some theoretical part here, right? For easy understanding. A star scheme is a mature modeling approach widely adopted by relational data warehouse. It requires modelers to classify their models tables either dimensions or fact. Dimension tables describes business entities, things you model, like entities can be product, people, places, all those things. Okay, just try to understand the crux of it. Dimension tables, what they are going to represent, that a product, people, places, concepts. The most consistent table you will find in the star scheme is date dimension, like a table having all the dates, right? Facts table stores observations or events, right? When you say events, a transaction happened, a purchase happened, right? All these are like events. You gone to a shop, you purchased something, an event. In the weather report, we are capturing the weather temperatures hourly. That is an observation, right? So a table that captures weather report like every hour, morning 1 a.m., 25 degrees, 2 a.m., 35 degrees. And we would be having few more columns, right? Like city. Instead of city name, we will be having city ID, correct? Like that. Sales orders, stock balances, exchange rates, temperature. A fact table contains dimension key columns that relates to dimension tables, right? So the fact tables are maintaining dimension table key columns, right? Determine key columns and numeric measures. The dimension key column determines the dimensionality of the fact table. So how many dimension tables are there? That is the dimensionality, right? While the dimension key values determines granularity, right? So, and also couple of more things like normalization is term used to describe data that's stored in a way that reduce repetition of data. Okay, we are going to reduce the repetition of the data. And a detailed example. See, consider a table of products that has unique key value like product key. The other column that describe the product characters like name, category, color, size. Now all these can be dimensionalized. Okay. In the denormalized table, everything is kept. So silver, color repeating, red repeating, category repeating. So instead of having these values repeated, we maintain the key column that will tells all the details about that particular product. Okay. Dimension tables used for filtering and grouping because dimension tables is going to have the product information. Say I want to know total sales related to this particular product category, right? I want to know what are the total sales from the city, Texas, like that. And fact tables enables the summarization. Now, when you say summarization, if you see here in the fact table, we are storing like total quantity, cost of the product, total cost and everything. So we can summarize this one. What is my total revenue? What is my, how many products I have sold, right? These all the things would be covered as a part of the dimension table. So, sorry, my bad, fact table. So dimension table enabling filtering and grouping. Fact table enables summarization. Okay. And how these are related? One to many. At any point of time, the dimension should be having a unique reference so that whenever a fact table is looking for a particular line item, it gets a single record. Okay. A well-structured model design includes tables that are either dimension tables or fact table. Avoid mixing two types together for a single table. So don't saying just saying don't read. Okay. A further details about surrogate keys, snowflake dimensions, and all those things. Okay. So we have covered the introduction, OLAP, OLTP, and we have seen the two theories of data warehousing, Ralph Kimball and Inmon, right? And we have seen the data warehouse, data modeling, and followed by star and snowflake schema with the normalizations and dimensions and fact table, right? So let me see if we have any queries. Okay, snowflake concept, right? So let me repeat the snowflake concept once again. Now, where is our diagram? Right? So here, one fact table is connected with one level of dimension tables, right? And this is looks like a star. That is the reason we are calling it as a star schema, right? Now, in this particular scenario, for this fact table, one of the dimension is the customer address. Okay. Now, if you see the customer address means we are going to store the name, address, their city, state, country, all those things comes. Correct. Now, what I observed is the city, whenever we are using city related information, right? I have a thousand, 1 million customers. Now, 1 million customers from the same city means I'm going to repeat the entire city name, state name, country name multiple times. So that means around 3 columns I am adding city name, state name, country. So all these three are repeating. Instead of what I'm going to do is I just create a city ID, right? A city table that is going to store all the city level information, whether name, state, country, or its coordinates, latitude, longitude, coordinates, all those things. Now this city table is going to be referred by customer address dimension. Okay, so instead of storing three columns, three values, I'm just storing only one column, right? So a dimension table further referring to another dimension table is called snowflake schema. Okay, like flow, right? Is it clear, Vyas? Any doubts or queries? Okay, so let me pause